Okay, guys, so this video is going to be about explosions, which is something that sounds new, but it's actually something pretty similar to what we've already seen. So this video is about explosions. Now, an explosion is not always what you think. All an explosion is when one thing becomes more than one thing. Okay, so we can think of this as the reverse of an inelastic collision. So you just worked on inelastic collisions, and for an inelastic collision, remember that we said that we had a skateboarder and a skateboard, and we said when the skateboarder runs and jumps on the skateboard, and then they both move together, that's an inelastic collision. Well, let's imagine this the other way around. So what if we started off, and let's go. Let's make him stand just like that. Okay. So what if we started off with a skateboarder on a skateboard, and the skateboarder jumped off? Okay, well, that's one object. When the skateboarder jumps off, any of you that skate, you know that what happens is when he jumps off, he's going to have some velocity that way, but the skateboard is also going to move that way. So one object became two, and this is a good example of an explosion. Now, it's going to look, doing calculations for an explosion is very, very similar to doing calculations for an inelastic collision, because it's still momentum before, is still equal to momentum after. Now the momentum before is just going to be mass times velocity, while the momentum after is going to be two objects, mass times velocity plus mass times velocity. So let's do a quick example. And I like this one. So we've all sort of heard that thing where if you're ever an astronaut out in space and you're drifting away from your ship and you need to get back to it, that you can just throw your oxygen tank away from you and it'll move you in the opposite direction. That's Newton's third law. Okay, so let's imagine our astronaut. I don't know how he'd have like a little visor thing, and he'd have like a big suit or whatever. Okay, so there's our astronaut. And let's say that our astronaut weighs 70 kilograms, okay? And initially, he is holding an oxygen tank that weighs 20 kilograms, okay? And let's say that they're not moving, all right? And what he's going to do is he's going to throw his oxygen tank that direction at a speed of 4 meters per second, and we want to know what is his velocity the other way going to be. Well, I know that I have to have mass times velocity for the whole thing, and that's going to be equal to mass times velocity plus mass times velocity of the two new objects. So for the whole thing, my mass has to be the 70 plus the 20. So I've got 70 plus 20 for the mass of the whole thing. Now this is going to be simple because they're not moving in the beginning. Their velocity is going to be 0. Now you'll see some examples where that velocity, there is an initial velocity, but for now it's going to be 0. Now, for my other two, I'm going to take one mass and the other mass and plug those in. So I'm going to have 70 and 20. Now, we'll do these because I'm multiplying. The velocity of the astronaut is what I want to know. That's my question mark, so I'm not going to put anything there. But I do know the velocity of the tank, so that can go in there. All right, so now we just have to solve this equation for v, which is simpler than you think, because this 0 right here makes everything 0. So this whole side is 0. And then I've just got 70v plus 20 times 4 is 80. Okay, now I'm just solving for v, so I'm going to subtract 80 from both sides. Negative 80 equals 70v. I'm going to divide both sides by 70 to get that v by itself. And 80 divided by 70 is going to make negative 1.14 meters per second. So I go back up here, and now I know that my astronaut ends up going negative 1.14, and that's meters per second. And that really makes a lot of sense, because if the tank is going to the right and the astronaut is going to the left, then they should have opposite signs. Because if two things are going opposite directions, then their velocities have to be opposite. So one has to be positive, one has to be negative. All right, try a couple on your own. Good luck.